There was a time not too long ago that people didn't wear seatbelts. If you got in the car with your buddy and you put your seatbelt on, but your buddy didn't, it was an uncomfortable feeling.
What's wrong, Mr. Safety? Don't you trust my driving?
Today we wear seatbelts for two reasons. One, it's the law, but two, it's been proven that seatbelts save lives.
Arc flash safety is evolving in a very similar way. You may walk into a situation where you are properly wearing a 40-calorie suit and you are working side by side with someone in a t-shirt. Who's right and who's wrong?
Just like the seatbelt example, it's an uncomfortable feeling. But since arc flash safety is now required by many companies, and the safety governing bodies like NFPA and OSHA have new standards, the electrical industry is starting to pay attention and do the right thing. How can you ensure that you're doing everything you can to keep your employees safe? Here at the Power Systems Experience Center, you can learn about arc flash safety and the solutions that exist to keep you and your people safe.
So what is an arc flash? An arc flash is an unintentional release of energy caused by an electrical fault. An arc flash event can reach temperatures of 36,000 degrees Fahrenheit, or 4 times the temperature of the surface of the sun. During the arc, copper can expand at 67,000 times its volume, very much like an explosion caused by dynamite. And if you're as startled as you would be in the case of an arc flash event, you would quickly inhale and breathe in that vaporized copper. About 2,000 arc flash incidents are reported each year, and as you can imagine, it is likely the actual number is significantly higher as workers are embarrassed or fearful of losing their jobs if they report a near-miss incident involving an arc flash.
Arc flash energy is measured in calories per centimeter squared. An arc flash label has 2 critical pieces of information on it: the calories per centimeter squared, or the energy released, and the distance that a worker would have to stand outside to avoid a non-curable burn if an arc flash were to occur. If you held a match 1 inch under your finger for 1 second, that would be approximately 1 calorie per centimeter squared, or just below 1.2 calories per centimeter squared, the amount of heat that would be required to cause a second-degree burn, which is the limit of what we call a just curable burn. As you can imagine, if you pulled your finger away quickly, as you would do when you touched a hot stove, or if you held the match 10 inches away, there would be less heat. This illustrates that time and distance are critical and somewhat controllable variables. Similar to an arc flash event, if we can control the time and distance of the arc flash, we can lessen the impact. Here at the Experience Center, we can show you options that reduce the time of the arc flash event and increase the distance of the worker to the location where the arc flash occurs.
This arc flash label indicates that the arc flash energy is 27 calories per centimeter squared. So in order to protect a worker from this amount of energy, they would have to wear a 40-calorie suit, like this one. A worker dressed in an 8-calorie suit would not be protected from a 27-calorie event. The clothing effectively acts as a thermal barrier to the arc flash event, protecting the worker from the thermal energy at a working distance of typically 18 to 24 inches. The second critical piece of information on this label is distance. This label shows that in order to avoid a second-degree burn, a person without arc flash personal protective equipment, or PPE, would have to be 18.5 feet away. The only way to operate on equipment from this distance without PPE is to do so with some type of remote control device or equipment.
These labels are created by our Power Systems Engineering Group, using models of electrical power distribution equipment data from your site with the sizes and settings of your protective equipment taken into account. This ensures that the calculated arc flash levels are accurate for your situation. Our PSE group has done thousands of arc flash studies and applied solutions for our customers' facilities and our own. The NFPA 70E standard serves as a guide defining the method that companies should use to perform arc flash analysis, labeling, and training of personnel. OSHA has used the NFPA 70E in the past, following a reported arc flash incident, but more recently has been proactive in their approach to arc flash safety. In 2015, OSHA released a final rule requiring that companies that own and/or operate their own power system equipment perform arc flash calculations and apply labels to their equipment. In addition, it requires that companies provide PPE and training regarding arc flash safety.
Eaton has nearly 100 solutions for arc flash safety. And here at the Power Systems Experience Center, we can introduce you to all of them. We focus on opportunities to reduce the arc flash energy by reducing the fault current, reducing the clearing time, and increasing the distance from the arcing fault to personnel. For example, to reduce the fault clearing time, the arc fault reduction maintenance system allows you to use 2 settings on a circuit breaker. One for normal coordination, one that is faster than instantaneous setting on the breaker. This second setting, when activated during a maintenance operation, bypasses the microprocessor to clear the fault even faster than a ZSI or instantaneous trip time. These lockable switches should be part of every lockout-tagout procedure. In this case, the arc flash energy is reduced from more than 20 calories to less than 1.2 calories during maintenance operations when faults are more likely to occur. Arc flash events may occur when you're racking in or out a circuit breaker. Using a robotic device like the RPR2 can keep personnel at a safe distance in case an arc flash event would occur. Medium voltage and low voltage arc resistance switchgear uses a plenum or chimney to vent away an arc flash event if it were to occur. This gear is built with additional reinforcements in the structure of the gear and the doors to maintain its integrity during arcing events. The idea with this gear is to do everything with the door shut, like this self-racking mechanism in our medium voltage resistance switchgear. The most common type of arc resistance switchgear is type 2B. With 2B medium voltage arc resistant gear, the low voltage metering, relaying, and control compartments are isolated from the gear with a separate door.
One of the most common times for an arc flash event to occur is when adding or removing a bucket in a motor control center. This flash guard bucket can be added or removed with the door shut, with a local or remote operator protecting the worker until the bucket is safely removed from the energized bus. This flash guard MCC takes the procedures and guesswork out of your hands, only allowing the disconnect from live bus operation to be done exactly the same way each and every time.
This low voltage assembly illustrates a very common yet very dangerous situation. The arc flash label indicates that the arc flash energy on the primary side of this breaker is 68 calories, well above the maximum allowed when wearing a 40-calorie suit. Yet on the secondary side of the breaker, it is only 14 calories. For a fault on the secondary, this breaker can trip quickly. For a fault just on the other side of this breaker, even though the fault current is the same, the energy is much higher because the clearing time of the nearest upstream device is intentionally delayed to compensate for transformer inrush and coordination. So how could we create a selectively coordinated system that compensates for the expected transformer inrush, but at the same time clears a fault on the line side of this main breaker quickly enough so that the arc flash energy levels are substantially lowered? Our VCPT solution allows us to use a medium voltage vacuum breaker and 2 protective devices to detect faults in different zones around this transformer. The most difficult fault location being the line side of this main breaker. With this solution, this medium voltage breaker can selectively determine how quickly to clear a fault, significantly reducing the arc flash energy to well below 10 calories during maintenance conditions. Arc flash safety is one of the most important issues facing our industry today. We can help you comply with the latest NFPA 70E and OSHA requirements by showing you options for analyzing your power system, applying labels, and training your people to minimize your risk of arc flash incidents.
As you can see, there are many things to consider when determining the arc flash level and methods of reduction for your power system.
Here at the Power Systems Experience Center, you can see the latest in arc flash mitigation techniques and learn about solutions that can help you with your arc flash safety program.
Contact us or your local Eaton representative to schedule a visit to the Power Systems Experience Center today.